Hello everyone, this is my fourth demo video, and in this video we are going to talk about domain and architecture. So first of all, what is domain and architecture? Domain in this Paytm area, it is all about understanding how payment works, including rules, security needs, handling transactions safely, and etc. As for architecture is a structure of a payment system, how parts like e-commerce platform, PayPal, and user account connects and works together. By designing the payment architecture with the domain in mind, the system stays secure, follow the rules, and works smoothly for handling transactions. That's why we include domain and architecture plays a major role part in our project. In this project, we are mainly talking about mi- microservice architecture. Let's just first see this flow diagram through which we can understand how our project works. As in the previous video, we have seen this diagram. This part of this diagram, the merchant side is which we do. It's our project. And the PayPal is an external system. In, in this project, we interact with external systems or the third-party apps like PayPal and connect it with our system to do payment services. As you can see, there are three layers of different three different layers in this flowchart. First one is e-commerce, which is a UI layer. First of all, let's talk about it. E-commerce application initiates the payment by calling create order. As you can see, it initiates the payment by calling create order, possibly through a PayPal SDK. This action generates an order ID, a unique identifier for transactions. Order ID is returned to the e-commerce UI. You can see it is returned to the e-commerce UI, which passes it to the backend server to process the payment. And payment can also be called a merchant server. The order ID is received by the server where it interacts with the payment module. The server processes payment requests and manages transactions, often handling often handling authentications, validations, and any required checks. This model interacts with external Paytm payment services like PayPal. The server uses the order ID to communicate with PayPal's APIs, directing the request to the links such as v2 slash checkout slash order endpoints. As we have seen in our previous video, we have used this link to connect our project with Postman. As for the external layer or the is the PayPal involves test and live environment. The server sends order ID to the PayPal, which can route the transaction to either test or live environment, depending on whether it is a development or production. In the in the test process, there is no money involved. as it is used by the developers to check and make the system with the help of PayPal. As for the live, it is where real money is involved. In the live environment, PayPal processes the payments and returns a confirmation or error status to the merchant server, completing the transaction process. As you can see in this diagram, first we create order with the help of PayPal SDK. It creates an order ID. Order ID later gets uh, forwarded to the payment services through which it can contact with PayPal's API and order ID. Then order ID go to the PayPal through which we can know whether our process has worked or not. And if it is an error, it's go back and send a message to the payment layer and it interacts with e-commerce where in the interaction phase we can see how a process worked or not. As you can see there are three layers. UI layer, also called as e-commerce application, which we users use. As for merchant server, it is a backend layer, so only developers know what is going on there. As for PayPal, PayPal is also called PSP or payment service provider, which is a third-party app. Let's discuss about payment systems. There are only two types of payment systems. One is card and second is APM, which full form is alternate payment method. In the actual world, only third party can do the payment related works. If you want to make your own system, you would need to have a government approval and regulation, etc. Not anybody can become a bank. Money is very serious in our world. It needs to be handled very carefully. So to do the payment, many third parties are available, such as Master Visa system or PayPal or Stripe systems. So and etc. So we cannot do that. We only need to make our e-commerce application because it making our own payment service such as PayPal, it would need a lot of work and very complex process. The companies deduct a small amount of money in every transaction. Even though it is a complex, you can do it, but with approvals by the government like license, and you also need time and maintenance and etc. to make your payment service work. It is better to use a third party apps. PayPal or PSP is working like an APM, also known as alternate payment method. Card payment, on the other hand, you can directly capture card details in your websites or application and give it to the third party for card processing. Card number is a very important information and other can deduct your money if they know your card details. In India, we use OTP system to make our transactions more secure. As you know, in India, the payment system is lot better than the other countries, as our banking system evolved with time and adapted to the large population, making our system more secure. Even the small transactions can be easily transferred through the online systems like payment and PhonePe and etc. Now, PCI DSS. So what is PCI DSS? Payment Card Industry Data Security Standard. Its full form is Payment Card Industry Data Security Standard. Is a set of security standards that the businesses handling credit card transactions must follow to protect the cardholder's data. It requires measures like encryption, access control, regular security testing, and a secure network. It helps prevent fraud and build customer trust and avoid penalty for data breaches. As we discussed before, so many don't want this kind of headache. So majority will decide not to capture card details directly as at their end. If they want to give card functionalities, they will use existing payment services provided. Now, first of all, we have to know how e-commerce works. In this diagram, we can see the three blocks of different different processes. As one is seller, an e-commerce, and a buyer. Seller is the one who sells the goods to the and uploads its goods to the e-commerce website. A buyer can look at his product with the help of an e-commerce website. And e-commerce website is an basically is a G graphical user interface which shows an application. It is an application in which we can see different products and choose which what we want. All sellers around the world upload their products in e-commerce website, so the buyers from all over the world can access e-commerce website and they can buy the goods. At the e-commerce website, there is a business account which needed to be created. It stores all the details such as name, phone number, address, and other details. The PayPal will be integrated with this and handle payments. This flowchart can be easily understood if we take Amazon as an example. Amazon buy do not buy the goods, they upload the seller goods in their website, and the people all over the world can access the application and orders the seller goods. The buyer proceeds with a checkout or makes a payment. The system directs the payment processes to PayPal through the linked business account. The payment will be later distributed to the sellers. PayPal involves PCI DSS, which makes it more secure and make transactions more secure as encryption and many other processes are involved. Microservice architecture. Wait a second. Yes, so now microservice architecture. Microservice arch Okay, so now we are going to talk about microservice architecture. Microservice architecture is a software design approach where an application is built as a collection of small independent services. Each microservice is responsible for specific functions such as user authentications, payment processing, or product catalog management, and operates independently from others. These services communicate with each other through APIs. Let's now talk about the key features of microservices. Microservices are decentralized and independent. Each service can be developed and deployed and scaled independently. Single responsibility, Single responsibility. Each microservice focuses on a specific task or a business function. Flexibility in technology. Terms are used in teams can use different languages, frameworks, and databases for each service. Improve scalability. Only the needed services are scaled rather than the entire application. Now let's talk about the advantages of microservice. First is resilience. Failure in one service doesn't bring down the entire application. Second, scalability. Services can be scaled independently based on the demand. And third, faster development and deployment. Small teams can work on different services in parallel, leading to quicker release. Microservices are commonly used in complex, large-scale applications where flexibility, scalability, and resilience are critical, such as e-commerce and financial platforms. Before microservices, there were technologies like monolith and S-Storage. Even though they both were advanced for their time, but got they got uh, less used when microservices comes into action. Microservices allows parallel working and many other features which makes large projects can work easily. As for monolith, we usually make the whole project without without the help of the other provided applications. Now let's talk about this diagram. This diagram shows a simple payment integration structure with two payment services providers such as PayPal and Calixta. Here's an Here we are going to talk how they interact with the main system. They represent two separate payment services providers that handle online transactions. PayPal is the most widely used payment gateway offering secure and convenient online payments, as Calyxa is another payment gateway provides similar transaction services, but may have its own unique features or compliance standards. As we can see, each provider has dedicated their own module or jar files. As for PayPal, it is paypal.jar file. As for Calexica, calexica.jar. In the Java-based architecture, a jar file, meaning Java archive files, is used to package Java classes and resources associated metadata, making it easier to import and use functionalities across the application. Each jar file contains all the necessary code, libraries, and configuration required to communicate with each payment provider's API. They handle tasks like initiating transaction, managing authentication, and processing payment responses. Now coming to the main module. The main component is in the diagram is likely the core application or a central module that manages interaction with both the payment providers. All the dependencies are stored in the main component. It is the it could act as an integration layer that connects e-commerce platform or application with the two payment gateways. This layer is responsible for selecting the appropriate provider based on factors like user choice, currency, or transaction fees, routing the transaction accordingly. The main module would use the PayPal jar file and Calixita jar file as needed, calling specific functions within those jar files to start a complete payment process. Now let's talk about is integration flow. When a user initiates a payment, the main module decides which payment gateway to use. For instance, if the user chooses PayPal, the main module will invoke PayPal.jar file to process the transaction. As for Calexica, it will choose Calexica. Each jar file handles its own provider-specific details, such as authentication protocols, data formattings, error handlings, allowing the main module to interact with them in a standardized way without needing to manage complex details of each provider's API. Benefits of this architecture modularity by separating each provider functionality into jar files. This architecture makes it easier to manage, update, or replace payment providers. For instance, if a new version of PayPal's API is released, only the PayPal.jar would need to be updated without impacting the rest of the system. It also provides flexibility. These setups allow the application to support multiple payment gateways, giving users the choice to pay their preferred method. It also enables expansion if new payment gateway needs to be added in the future. It also provides maintainability. With each provider's code isolated in their own module, developer can work on one payment provider without affecting the functionality of the other. Troubleshooting and testing can also be done independently for each payment provider. It also provides scalability. By isolating each provider into its own jar, the system can scale as transaction volume grows, handling traffic to each provider efficiency. Now, to summarize the whole diagram and the concept, the only thing that can be said is that this architecture allows main module to work with multiple payment providers seamlessly by using dedicated modules for each provider. It provides flexibility, modularity, and scalability for handling online transactions across different gateways, ensuring a smooth and adaptable payment integration. As to summarize this whole project, can say that in designing payment system, domain-specific principles play a crucial role in ensuring that the architecture is secure, compliant, and user-friendly. These principles guide how payment processes are structured, protecting sensitive data and ensuring a seamless user experience. Now, let's first recap what we have learned in this project, in this PPT, or in this video. First is security. A robust payment architecture minimizes vulnerabilities by isolating key components and encrypting data, ensuring the sensitive information like credit card details is protected at every stage. This is crucial for maintaining trust and preventing breaches. The second we learn in this video is compliance. Adhering to the standards like PCI DSS is mandatory for any organization handling payment data. These standards enforce strict data to protection measures, reducing the risk of fraud and ensuring legal compliance. We also get to know about the user experience. A well-designed payment flow streamlined through the microservices allows for a faster transaction and reduced friction during checkout. This keeps users engaged and improves conversion rates of the e-commerce platform. Now, the last but not the least is financial integrity. Now, let's talk about financial integrity. By establishing a clear domain-specific rule, the system ensures an accurate transaction handling, minimizes error, and maintains overall financial integrity. This prevents issues like double charges or data inconsistencies. In essence, domain-specific design principle ensures the payment systems are not only efficient but also maintain high standards of security, compliance, reliability, which are essential for long-term success and user trust. As to briefly summarize, domain-specific design principles ensure payment systems are secure, compliant, and user-friendly. Strong architecture protects sensitive data, meet legal standards like PCI DSS, and provides smooth user experience. This setup enhances transaction security, reduce error, maintain financial integrity, building user trust, and supporting long-term business success. Now, I want to thank you for watching this video till the end. Thank you, everyone.